Hello and welcome to FEM Expert. Today we will present you a basic tutorial in which we will show you how to use beam, shell and volume type elements all together in an Ansys simulation. As usual, we will start with the Ansys interface that you probably already know. In this simulation we will generate a table made with a 1 square meter made of aluminum with 4 legs made of steel. And on top of that we will place a cube of steel using volume type element, and we will see how the structure behaves. The first step therefore is to create the key points of the table, and in order to do that we're going to go to preprocessor, modeling, create key points, and we're going to create the key points in the active coordinate system, which is 0. It's here named as 0 and is the one that you can see on the screen. So for the first key point we're gonna have 0, 0, 0, apply. For the second key point we're gonna have 1 meter 0, 0, apply. For the third key point is 1, 0, 1, and for the fourth key point is gonna be 0, 0, 1. When we have done that, because they're on the XZ plane, we have to go to the isometric view to view the points. We have in 1, 2, 3, 4. We're going to first create the area in order to be able to visualize everything easier. I'm going to create the area arbitrarily through our key points. As we said before, you have to do them clockwise or anti-clockwise. So we're going to do it 1, 2, 3, 4. Okay, even with the cursor you lose the stuff. You can go to plot and plot areas, lines, key points instead, etc. We're gonna go to the bar and gonna type gplot, which means global plotting, which shows all the entities that we have created. Here we have areas, lines and key points, because the areas need to have lines and key points to be defined. Now we're gonna define a little area here on the middle of the table, which is gonna be the part where the volume sits. So I'm gonna create another key point. The last key point that we have created is the number 4. We can look at that by listing the key point, and the last key point that we have is the number 4. So I'm gonna, again in the active coordinate system, I'm gonna define key point number 5 at 0.25, then 0, and on Z we're gonna have on 0.25 too. We're gonna apply. I'm gonna move this so we can see where the point is, and there we have the point number 5. For the key point number 6 we're gonna have 0.5, 0 and 0.25. For the key point 7 we're gonna have 0.5 is the same coordinate. On here we're gonna have 0.5 on Z. Okay, and for the last key point, the number 8, we're gonna have 0.25, 0 and 0.5. Okay, and we have the key points for the next area we're gonna create. Here we're gonna create another area arbitrarily through our key points 5, 6, 7, 8 again. And as you can see, there's 2 areas. They're not too easy to be differentiated, but you can see the lines. You can actually go here to the plot controls, go to the numbering and activate number of areas. You can use colors and numbers, hit OK, and you'll see that there are 2 numbers for 2 areas. Here the thing is, the numbers are located at the center of the areas, let's say the mass center of the theoretical mass center of the area. So for the big one we have it right here, and for the small one we have it there. At least you can tell there's 2 different areas, and depends on Ansys. Multiple times it will show you different colors for these areas, but this isn't right now. It's not the case. The colors that Ansys chose for these areas are exactly the same. So we're gonna go back to gplot, and now we're gonna do an operation, because these 2 areas do not share anything. They're not in contact, they don't know each other, they don't interact with each other. So for this tutorial we're gonna take this area from the main area. In order to do that, there's many ways. You can chop this area, you can intersect them somehow. There's many operations, but we're going to use what is called the area overlap. So for that, we're going to go to operate, booleans, and we're going to overlap areas. I'm going to select area number 1 and area number 2. After we do that, what you'll see is that Ansys has renumbered the areas. Now we have area number 2 and area number 3, and that these areas actually I'll show you. We'll do a select entities. We're going to go to areas, and we're going to select from full this big area, and we're just going to look at it. And you'll see that this area now is like a table with little hole on it. To select all, we can go here and type all cell from all select. It's going to select all the entities again. You can see everything the same way it was. So now we have done that. We're going to check if there's no extra lines or anything doubled. In order to do that, we're going to do the LLIS line list comma pick, and we're going to select each one of these. So if there's 4 lines, everything, the model is right. Okay, so now what we have to do is we'll copy the key points downwards for the legs and create the legs of the tables, and then we're going to create a volume of the metal piece based on the area number 2. In order to do that, we go to copy, key points, we select these 4 corner key points, we hit OK, we're going to move them minus 0.5 meters on the Y direction. We click OK, you see a lot of points. One of the best things you can do here is gplot again, and you'll see the key points. You can rotate the model a little bit, so we have this point here clearly visible. And now we're going to create the legs with lines, straight lines. We're going to select 2 each pair of key points we want to use for those lines. So now at this moment we have the table and the legs. Now we want to create the volume for that is going to sit on the table. For this, we're going to use a similar approach. We're going to create copy the key points. I'm going to select this key point, any of the corner key points, and we're going to copy it on a positive way on the Y axis at 0.2. We're going to go again to gplot. We can see the area and the key point. Again, we're going to we're going to create a line. Oops, sorry. We're going to create a line between these. Sorry, we are going to create a straight line from these 2 key points. And now what we're going to do is extrude like we did in the previous tutorial, but this time we're going to extrude an area to obtain a volume. So operate extrude areas along lines. So we're going to extrude this area, okay, along this line, okay. So now we have our volume. And you'll see in the global plot it tells you we have volumes, areas, lines, and key points. As we said before, when you use the Boolean operations, a very good thing to do is go to the numbering controls and merge items, because you'll have repeated items. You got to select key points here, okay, and that way it will list these lines. There's only one line and that's it. Okay, so now we have our model. We'd actually go to the numbering and deactivate the numbering because we know what we have and we don't need those numbers around there. What we'll do now is define the volume and define the properties, the element types, define the properties, the material properties, and assign them to the model. So the first step is to go to the element type, add a delete. We're going to add the first element type is going to be the beam 188, apply. The second element type is going to be the shell 181, apply. And the third one is going to be the solid brick 8 node 185, okay. So we have beam, shell, and solid. We can now we don't need real properties for these materials, but we need to define the material properties. So the material models are going to be for a structural, linear, elastic, isotropic. For the first material, we're going to use the steel, 2.1 exponential 11 for the Young's modulus and 0.3 for the Poisson coefficient. The density is 7,800 kilograms per cubic meter. And for the second material, we are going to define, and again, an isotropic elastic material with 6.9 exponential 10 aluminum Young's modulus and 0.33 the Poisson's coefficient. And in the density, we're going to have 2,550 kilograms per cubic meter. We have both materials defined. You can make them write down somewhere that number 1 is the steel and number 2 is aluminum. Look at this. Now we're going to define the sections. For the section, we're going to first define the beam, common sections. For this time, we're going to use a 40 by 40 by 3 millimeter beam. We have the idea number 1, and it's going to be a hollow rectangular profile. So here we put 40 divided by 1,000, one side, 40 divided by 1,000 on the other, and 3 divided by 1,000 on the other ones. You can actually copy and paste these values. Well, it's not allowing me to do it, but you can do it if you copy it from a text file to make it faster and not to waste so much time. Because as you can see, W's are the width and height of the profile, and the T1s to T4s are the thickness of each side. But because we have the same thickness, it's just this profile. We can preview the profile that we have. It's going to be a square rectangular profile. And we can select OK. Go back to Gplot, see our model. And that will be for the legs. And for the shells, we need a layup, edit, delete. The name is going to be 4 millimeter thickness table. The thickness is going to be 4 divided by 1,000 because we're using millimeters and we're working on meters. Mid plane offset, material ID, everything is the same. We just hit OK. Okay, so now we have the element type, the material properties, the sections defined, have the model. We just have to tell Ansys which parts of this model are what and what properties do they have. So for that, we're going to go back to the plot controls, numbering. We're going to activate the areas because we might need to use them in a little bit. We're going to go to meshing and define the mesh attributes. First, we're going to do the lines because they're the easiest, the legs of the table. So pick lines. We're going to pick this line, that line, that line, and that line. We're going to hit OK. And we're going to have material number 1 because they're going to be steel. They're going to be type 181 beam, and they're going to be a 40 by 40 by 3 millimeter section. We're going to hit OK, and we have the properties for them. Now we're going to pick the areas, but in order to do that, there's a problem because we have to select the area at the bottom of the volume and tell it it's part of the table, because otherwise we're going to have a table with a shell having a hole that is connected through 4 lines to a volume, a heavy volume. So in order to do that, we're going to go to select entities, and here we're going to go to areas, attached to, no, we're just going to select these areas from full. I'm going to hit OK. I'm going to select the big area. As soon as we move, we'll see that we lost the area in the middle. So in order to select that one again, we can go to select entities again. We're going to select areas by num and pick, but we're going to choose also select. Then we hit OK, and we have to find that area. You can click and move your mouse around to see what you're picking. We're going to hold it there. OK, and as soon as we look, we can actually go to plot areas to make it easier. We have the area number 2 and area number 3. So we're going to pick these areas and tell Ansys that their properties are, they're material number 2, aluminum, they're type shell 181, and they're 4 millimeters thickness. Okay, so now the last thing we have to do is we go back to the Gplot. We can do the old cell to select everything. We can go back to the Gplot and we can pick volumes for the properties. We're going to pick this volume, which is the only one we have, and the material numbers, material properties are the volume is a steel and is type 185. There's no other properties because the volume type elements are defined by themselves. So at this point we have everything we needed. We're gonna deactivate now again the numbering so we don't have problems with the colors. Now we can see the material. What we're seeing here are the different materials or the different element types, which is anyways good. So what we need to do at this point is we have our model completed. We need to mesh it. So in order to mesh these things, we need to again be careful, because when the models are a little bit more complex, they have more elements, you have to be aware what you're doing. It's not, you can't just go and mesh everything at once. So what we're going to do is go to the mesh tool, set a global dimension of 0.1, that would be 100 millimeters per element. We're going to set OK, that's going to be influencing the volumes, and most of the other stuff will just go one by one. I'm going to do a hexahedral mesh with mapped properties. I'm going to select the volume, hit OK, and we have the volume meshed. Now we're going to go back to plot areas, because we had the volumes but not the areas meshed, and we're going to raise the menu again, do the areas. For the areas we're going to select, for this area we're going to select again a size of, let's see, 0.15, so it's a little bit of a bigger element, because if we do it too big, there's going to be some very big discrepancies. So let's do it 0.2, and I'll show you what happens. Okay, we're going to hit OK, raise the model this again, and we're going to mesh areas quad. You cannot do it mapped because area number 3 is not a regular area, so we have to do a free. We're going to select mesh, and we're going to select that small area and this area. We're going to hit OK, and because the fact that it gave us a warning that the shape have revealed 2 out of 51 elements that do not have the proper shape. We can look at them, we can look at the meshing, but what we'll do is that happens due to the fact that here the meshing has to be 0.1, but then when it's getting closer to the edges it has to be 0.2, because that's what we told the program to do. So it gets into this weird shaped area. So we're gonna clear this. We're gonna clear this meshing. We're gonna do it by clear. We're gonna clear this and this. We're gonna refresh the model, plot areas, and we're gonna go again and mesh it, set the size for this area to be 0.1 again, the same as the other one. I'm gonna go back again and do the meshing, mesh that area, and that area. And now we don't have any problems, and the meshing looks actually quite good. Now what we'll still have to do is mesh the lines. So we're gonna go on a Gplot, move the model a little bit so it's easier for us to pick up stuff. Do the right hidden menu. We're gonna just mesh the lines, not set any dimension criteria. Mesh and select all those 4 lines and hit OK. And now we have the model has been meshed. If we want to look at how it actually looks in reality, we can go to plot controls, style, size and shape, and activate the E-shape option. We're also going to raise this menu and close the meshing things. And here you can see the legs, how the legs look. You can see the thickness of the table, and you can see the volume on top of the table. So now we have everything settled. We're going to go to solution, define loads, apply structural. We're gonna restrain the table. We're gonna put displacement on key points. We're gonna select the 4 bottom leg key points. All degrees of freedom are equal to 0 to have it restricted, and we're gonna put the inertia, the gravity, on global. This is gonna be the global acceleration, which is gonna be 9.81 meters per square second. And looking upwards, as we said before, because it's an inertial gravity, it's not exactly, it has to be the opposite way than the normal way you used to have it. We're gonna see the arrow as soon as we do that. And the next step is to go to solve, current LS, okay, solution is done. We're gonna go to general post-processing, read the results, last set, anyway we only have one set. We're gonna plot results, contour plot, null solution, degrees of freedom, displacement vector of sum. And here we can see with the each shape option activated, we see what we would expect. The table is bending under the weight of the steel box, which has to be pretty heavy. We have the value of the bending, and we see that the legs are doing its job. We're gonna go on nodal solution again, and we're gonna plot the stress of misses. I'm gonna hit OK, and as you can see, the stress is concentrated around the corners and around the place where the weight is placed. You can look at many things. You can go and zoom in, look at the stress here, and other things. So finally, I'm going to show you another thing, the vector plot of predefined translation. We can look at the translation and see, you can see here how actually everything is deforming, what way is going, the direction, even the top of the mass, because it's bending the table, is moving. You can look also at the rotation. This is a rotational vector, how the table is rotating too. And well, now you will, after this tutorial, probably will know how to use all of these element types. For now, I'm gonna go and quit. And hopefully at this moment you will have the minimum requirements to use all of these element types together. You gotta be careful when using them and having some criteria on how to do it, but we hope you will get the base on how to do it. We would like to thank you for your attention, and we hope you enjoyed this presentation. For more tutorials, please visit our community and follow us on the social media.